Hey everyone! Welcome back to our C# tutorial series. In the last video, we delved deep into arrays, a fantastic way to store and manage collections of data. But today, we're stepping it up a notch with a more flexible data structure, lists. Lists in C# are incredibly versatile. Unlike arrays, which have a fixed size, lists can dynamically grow and shrink as you add or remove elements. This flexibility makes lists the go-to choice for many scenarios where the number of elements might change over time. In this video, we'll cover what lists are, how they differ from arrays, and how to use them effectively in your programs. By the end of this tutorial, you'll understand when to use lists over arrays, how to perform common operations with lists, and why they are so powerful in C# programming. So, let's get started. Let's begin with the basics. A list in C# is a collection of objects that can grow and shrink dynamically. Think of a list as an array that doesn't have a fixed size. If you've ever worked with arrays and felt limited by their fixed size, you'll find lists to be a breath of fresh air. Here's a simple way to understand the difference. An array is like a row of lockers, where you must decide in advance how many lockers you need. A list is more like a shopping bag. You can keep adding items to it without worrying about running out of space, and you can also remove items as needed. This dynamic nature of lists makes them ideal for situations where the amount of data isn't known beforehand or where you need to frequently add or remove items. Let's move on to how we can create and initialize a list in C#. The list T class in C# represents a list of objects that can be accessed by index. Here, T is the type of elements in the list, just like how arrays have a specific type. Let's say we want to create a list to store the scores of players in a game. Here's how you can do it. In this example, list int declares a list that will store integers. Player scores, add, 10, adds an integer value to the list. The add method appends elements to the end of the list. The for each loop iterates through each element in the list and prints it to the console. When you run this code, it will output. That's how simple it is to create and initialize a list. Notice how we didn't have to specify the size of the list. You can keep adding elements as needed. Now that we've created a list and added some elements, let's see how to access and modify these elements. Accessing elements in a list is just like accessing elements in an array, using an index. Let's go through an example where we modify the score of the third player and then print all the scores. In this code, player scores 2 equals 35 modifies the score of the third player. Remember, list indices are zero-based, just like arrays. Player scores count gives us the number of elements in the list, which is handy for loop iterations. When you run this code, the output will be. You can see how easily we modified the score. Lists are not only dynamic in size, but they're also easy to work with when it comes to accessing and modifying data. One of the biggest advantages of using lists is the ability to easily add and remove elements. Let's take a closer look at how this works. You've already seen how to add elements to a list using the add method. But what if you want to insert an element at a specific position? You can use the insert method. Similarly, you can remove elements using the remove method or remove at if you know the index. Let's see a full example. When you run this code, the output will be. Notice how we inserted 25 at the third position and removed 40 and the first element, 10. Lists provide you with the flexibility to manage your data efficiently. Lists come with a variety of methods and properties that make them even more powerful. Let's look at some of the most commonly used ones. Add adds an element to the end of the list. Insert inserts an element at a specified index. Remove removes the first occurrence of a specific object. Remove at removes the element at a specified index. Clear removes all elements from the list. Contains checks if an element is in the list. Index of finds the index of the first occurrence of an element. Sort sorts the elements in the list. Reverse reverses the order of elements in the list. Let's see an example where we use some of these methods. When you run this code, the output will be In this example, you can see how we checked for an element, found its index, sorted the list, reversed it, and finally cleared it. Lists in C# are incredibly powerful, and these methods give you fine control over your data. It's challenge time again. Let's see if you can apply what you've learned about lists. Create a program that manages a high-score list. Your program should 1. Allow the user to add new scores. 2. Automatically keep the list sorted in descending order. 3. Display the top 5 scores. 4. Allow the user to remove a specific score if needed. Here's a quick example to get you started. Give this challenge a try and see if you can make your program dynamic and flexible. Remember to keep your list sorted so that the top scores are always at the front. Once you're done, share your code in the comments or with a friend. And that's it for today's lesson on lists. We've covered a lot, from creating and initializing lists to modifying them, and using the various methods and properties that make lists such a powerful tool in C#. Remember, lists are incredibly versatile. Whenever you're dealing with a collection of data that might change in size, a list is likely the right tool for the job. In our next video, we'll dive into another exciting topic in C# dictionaries. Dictionaries allow you to store data in key-value pairs, making it easy to look up values based on a unique key. It's a must-know for any C# developer, so be sure to tune in. As always, if you enjoyed this video, don't forget to like, subscribe, and hit the notification bell so you won't miss the next one. And if you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching, and I'll see you in the next video.